Hi, welcome to Everyday Math. Today's lesson is going to be lesson 5.4. So what we did yesterday, or what we did in lesson 5.3, is we talked about when we're adding fractions and mixed numbers, a way to kind of separate it. A lot of the times what I do is you can use a stacked method, which is kind of like what you would normally do with subtraction. So I'm going to show you a couple of ways today. That's going to be one way that I show you. There are times where you might have to borrow. So this is where we're going to pull information from the lesson that we did in Unit 2 and Unit 3 when we renamed those fractions. Remember, I gave you a fraction or a mixed number, and you had to rename it as many ways as you can. That's what's going to come into play with subtraction, especially when you borrow. So when we're going through this today, if there is something that you don't remember, please, please, please ask. Or on my YouTube channel, don't forget there's those extra helpful hints, and on that channel you will see a video that's renaming fractions that has that stuff on there for you. And I'll put the link for you as well in the lesson. All right, so I'm going to make myself smaller. We're going to be in our Everyday Math Student Journal Volume 2 on page 163, and we're going to be working with lesson 5.4. So with this assignment, the first thing that it's going to have us do is it's going to have us make some estimates again. The importance of making an estimate is to know if your answer is close, right? So if I make my estimate 4 and 4/5, to me that's really close to 5. 1 and 1/5, that's really close to 1. So 5 minus 1, my answer would be about 4. Now if I actually do the subtraction, and my answer ends up being like 2 and 1/5 or something like that, then you know your answer is going to be wrong. This estimate tells you where you should be close to. So that's why it's important to do your estimate first. Now, the stacked method, this is something that we've done. This is my favorite way to do addition and subtraction of mixed numbers. Basically, I look at each number, each side one at a time. So I look at my fraction side, and then I look at my whole number side, and I kind of think about them as two separate problems. Okay? It's going to help me out most of the time. So let's do this way. Okay? 4/5 minus 1/5. Well, they have the same denominator, so that's easy. 4/5 minus 1/5 is 3/5. I don't have to borrow. I'm good. All right, now let's look at our whole numbers. What's 4 minus 1? 3. Is 3 and 3/5 close to 4? Yeah, I would say so. That is one way that you're going to do this. Let's keep going. 3 and 1/3 minus 1 and 2/3. All right, 3 and 1/3, I'm going to say that's close to 3. 1 and 2/3, I'm going to say that's closer to 2. 3 minus 2 is going to be 1. It's going to be kind of close to 1. All right, let's try our stacked method first. 1/3 minus 2/3. I'm stuck. You can't do it. You cannot subtract 1/3 minus 2/3. All right, there's a couple options when we get to this. We can draw a picture. Could work. Or we can rename our fractions and our mixed numbers. I'm going to rename this time. Remember, to rename my mixed number, I'm going to use the SAD method. Subtract a whole. So 3 minus 1 is 2. Add my numerator denominator. 3 plus 1 is 4. And then my denominator stays the same. And now I can subtract. 4/3 minus 2/3 is 2/3. 2 minus 1 is 1. Absolutely, that works. Now, there are a lot of options for this. The stacked method and the borrowing and regrouping, this is one way to do this. There are a couple of other options that I'm going to go through with you. Okay? One option that we can do is where you make both of them into an improper fraction. So 3 and 1/3 minus 1 and 2/3. Okay? The first thing that you're going to do is make each of them into an improper fraction. So you're going to use MAD. Multiply. 3 times 3, 9. Plus 1 is 10, denominator stays the same. 1 times 3, 3, plus 2, 5, denominator stays the same. So 10 thirds minus 5 thirds equals 5 thirds. And then you have to rename this into 1 and 2 thirds. Same answer, same process. This sometimes might be easier, especially when you're working with larger numbers. Okay, so absolutely, you can rename. You can make into an improper fraction. Or, I'm a picture person, I'm a visual person, so guess what? I'm going to draw a picture. I'm going to start by drawing 3 and 1/3-ish. Then I'm going to take away 1 and 2/3. So I'm going to take away 1 whole. And I have to take away 2/3, but I need to break one of them up first, right? So I'm going to break this one up. And I'm going to take away 1/3, 2/3. And now, based on my picture, I can see that I still have 1 whole, 1 still put together, and 2/3 left. Using the picture method is probably one of my favorite ways to do this, just because, again, it's a visual way to see the problem, and it's a good way to visualize and understand what is happening. Okay, you do have to borrow, you have to do a couple of other things. So if the picture method works for you, great. If not, you can look at one of these other options. All right, let's look at the next question. So my answer for here we said was 1 and 2/3. Let's look at this next one. Okay, 9 tenths minus 8 tenths. 9 tenths is close to 1. 8 tenths is close to 1. So 1 minus 1 is going to be 0. Let's figure it out. 9 tenths minus 8 tenths. Super easy. 7 tenths should have been your answer. Absolutely, 7 tenths. This one's super easy. I'm going to draw my picture. And I'm going to separate into tenths. Hold on. There's fifths. There's tenths. All right, 9 tenths minus 8 tenths. 1, 2, 3, 4, 5, 6, 7, 8. How many pieces do I have left? 1. I don't know why I said it was 7 tenths. It's supposed to be 1 tenth. 9 minus 8 is 1 tenth. Awesome. I know I kind of tricked you guys and I kind of said something a little wrong earlier. I'm just checking to see and make sure you're paying attention. I'm just kidding. All right, let's try that next one. 3/4 minus 1/3. Okay, 3/4. 3/4. What would your estimate for this one be? For me, I would say 3/4 is close to 1. 1/3 I would say is about half. So 1 minus a half is about half. That's what I would say. All right. I know that I can't subtract this until I find my common denominator. I just can't. It won't work. So what would my common denominator be with a 3 and a 4? All right, I'm going to make my t-chart. 3 and 4. 3, 6, 9, 12. 4, 8, 12. My common denominator will be 12. All right. Whatever I do to the bottom, I do to the top. So 9/12 times 4. Whatever I do to the bottom, I do to the top. 4/12. So 9/12 minus 4/12 equals 5/12. Done. Is 5/12 close to half? Well, yeah. Half of 12 is 6, so it's really close. All right, let's look at number 5. On number 5, I want you to try to do the estimate on your own. 3 1/3. What is that close to? Minus 1 1/2. What is that close to? What is your estimate? All right, 3 1/3 I'm going to say is close to 3. 1 1/2 I'm going to say is close to 1 1/2. If I take 3 minus 1 1/2, well, I mean, that's half of it. My answer is going to be 1 1/2. My estimate should be close to 1 1/2. If you said it was close to 2 because you did 3 1/2 minus 1 1/2, that's okay. As long as you're around that number, you'll be fine. All right? Now, let's look at this. 3 1/3 minus 1/2. The first thing I have to do is I have to find my common denominator. This common denominator should be easy. What is your common denominator between thirds and halves? For me, I'm choosing the smallest common denominator. 3, 2, make my T-chart. 3, 6, 9, 12. 2, 4, 6, 8, 10, 12. Now, technically, I could use 12, but the number 6 is also in both columns, so that's the one I'm going to use. It's the smallest or least common denominator. All right, I got to make my denominator into a 6. So I multiply my 3 by 2. Whatever I do to the bottom, I have to do to the top. So 2/6. All right, down here, I multiply my 2 by 3. Whatever I do to the bottom, I have to do to the top. So 3/6. So what I do is I rewrite my problem off to the side. That shows my steps, that shows my process. All right, 3 2/6 minus 1 3/6. Can I subtract 2/6 minus 3/6? Nope. I'm going to have to borrow, so I'm going to have to rename. When I rename this, I'm actually going to rename it this time again, and I know that I did that with the last one, but I want to really show you how to do that. To rename your fraction, you're going to, and we're going to do them as improper fractions, all of them. Okay, so we're going to do the MAD method. So 6 times 3 plus 2 is 20/6. 6 times 1 plus 3 is 9/6. So 20/6 minus 9/6. What is 20/6 minus 9/6? I'm not pausing this time because I want to see your work. Well, 20 minus 9 is 11/6. Now, I don't like that. It's not pretty. Don't like it at all. How do I rename that mixed number? Or improper fraction. Take this improper fraction, please write it as a mixed number. What is 11/6 equal to? All right, if you say 11/6 is the same as 1 5/6, you are absolutely correct. Absolutely correct. All right, let's do number 6. 10 1/5, I'm going to say is close to 10. 4 2/3, I'm going to say is close to 5. 10 minus 5 is about 5. Making it simple. I want you to do any method you choose. If you want to make them as improper fractions first, fine. If you want to rename like we did earlier in the lesson, fine. Or if you want to draw a picture, fine. Choose the way that works for you. See if you can find the answer to this question. What is 10 1/5 minus 4 2/3? All right, to do this question, I'm going to do a picture way this time. First of all, I'm going to find my common denominator. All right, I have a 5 and a 3. Okay, 5, 10, 15. 3, 6, 9, 12, 15. I have my common denominator is going to be 15. To make the 5 into a 15, I'm going to multiply by 3. Whatever I do to the bottom, I do to the top. So 10 and 3/15 would be how I rewrite that problem. All right, times 5. Whatever I do to the bottom, I do to the top. So minus 4 and 10/15. All right, I'm going to draw a picture. I know that I can't do 3 minus 10, so I'm going to use a picture to help me. 2, 3, 4, 5, 6, 7, 8, 9, 10, and 3/15. All right, so if that's about a fifth, that's about 3/15. Ish. All right, here we go. Taking away 4 and 10/15. 1, 2, 3, 4. All right, I'm going to separate this into 15ths. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, here we go. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? I think I had an extra line there. 1, 2, 3, 4, 5, 6, 7, 8. 8. All right, so 1, 2, 3, 4, 5 holes and 8 left over out of 15. That's how you do it, guys. The picture is a little tricky to understand. And I understand that, especially when you get into a larger denominator, it's harder to see. I understand that. That's why you need to have other ways to do this problem. So you know me, we say check your math all the time, so guess what we're about to do? Check our math. We said 10 and 3/15 minus 4 and 10/15. Right? Let's do our math. I'm going to rename this. 10 turns to a 9. 15, 16, 17, 18. I subtracted a whole, added my numerator, denominator, and my denominator stays the same. 18/15 minus 10/15 is 8/15. And 9 minus 4 is 5. We did it right. That's how you would do that question. Now, just like last time, there are a few different mixed numbers and practices that we need to do. We're going to do one of these together, and then you're going to try the other ones during your, we're going to do number 1. And you're going to try to do the other ones during your lessons, okay? So your teacher, Miss Gilman, or if you're with somebody else, will probably go over these during your actual live lesson, so make sure you're ready to take notes. So it says fill in the missing numbers. So 5 and 1/4 we're going to rename. Okay, this is where we're going to do that method that I showed you before. Subtract a whole. Add your numerator, denominator. Denominator stays the same. 8 and 7/9. Subtract a whole. What's 8 minus 1? 7 plus 9 is 16, and my denominator stays the same. Remember? Now this one is going to go the opposite direction. What do you think the answer would be? What is the original mixed number if after I rename it, it turns into 3 and 9/6? What do you think it's going to be? Basically, for just moving backwards, I'm going to add a whole. So 3 plus 1 is 4. 9 minus 6 is 3, and my denominator stays the same. That's how you do it. All right, I want you to try to work this through on your own. When you're with your teacher, he or she will go over the rest of this with you. If you're in my groups, make sure you're logging in during our Zoom. We will go through the rest of these questions together. Subtracting fractions can be tricky, but Just like with anything else, just like when I'm teaching you any other method, remember I try to show you several different ways to do it. So make sure that you are finding a way that works for you. Have a great day, guys.